Imagine waking up one morning, checking your phone and seeing a single message. You've been hacked. Your heart skips. Your mind races. Your bank details, private messages, photos gone or exposed. That sinking feeling. It's what millions fear every day in our digital world. But what if we could make hacking obsolete? That's the promise of a new technology coming from a place few expected to lead the charge: China. And at the heart of it, a tiny satellite just 23 kilograms orbiting silently above Earth. Its mission? To deliver unbreakable quantum-level encryption that could change cybersecurity forever. Could China be on the verge of a scientific revolution that redefines the internet as we know it? Or is this just another overhyped sci-fi fantasy? Today we take you deep into the science, the skepticism, the stakes, and the stunning potential of China's quantum leap. Keeping secrets isn't new. Encryption has existed in one form or another for thousands of years. The ancient Romans had their tricks. Julius Caesar, for instance, used one of the earliest known encryption systems, what we now call the Caesar cipher. It was brilliantly simple: shift each letter in a message, a fixed number of steps along the alphabet. A becomes D, B becomes E. A simple shift of 3 letters transformed readable text into gibberish. But the real magic was in the key. The number of spaces shifted. As long as your allies knew it, they could decrypt the message. Enemies, not so much. Fast forward to modern times. Encryption has grown from shifting letters to relying on deep mathematics. We use keys made from massive prime numbers. Encryption now protects everything from WhatsApp chats to national secrets. But all encryption, even the most advanced, shares one vulnerability: the key. If someone intercepts your key, your secrets are theirs. And as computing power grows, brute forcing, systematically guessing every possible key gets easier. Here's where things get weird. Quantum weird. In the 1980s, physicists asked a bold question. What if we could use the very fabric of reality to protect secrets? Quantum mechanics, after all, plays by different rules. A particle can be in 2 places at once, superposition. Measuring it collapses it into a single-state observation effect. And 2 particles can become entangled so that what happens to one instantly affects the other, being across distances. Quantum key distribution. QKD was born from this idea. Imagine sending a key not as numbers, but as individual particles of light photons. Any attempt to intercept them would be instantly detectable. Why? Because observing them changes them. That's not just theory, it's quantum law. In 2016, China launched Mozi, also called Michus, the world's first quantum satellite. Its mission test if QKD could work from space. The results? Spectacular. Using entangled photons, Mozi transmitted quantum keys between ground stations in China and Europe, distances of over 7,600 kilometers. Then in March 2025, a new milestone: China's upgraded microsatellite conducted the first successful intercontinental QKD with South Africa, spanning 12,900 kilometers. A record. That's like whispering a secret across the planet and knowing if anyone eavesdropped. Why does space matter? Simple. Photons traveling through fiber optic cables degrade. Space, being a vacuum, preserves them better. Fewer interactions, fewer errors, more secure transmissions. And Mozi isn't alone anymore. China is building a constellation of quantum satellites to blanket the globe in unhackable key distribution. That's not science fiction. That's their 2027 goal. So is the game over for hackers? Not quite. Quantum key distribution secures the key, not the message. Once the key is safe, the message still travels through conventional channels encrypted with that key, but the content could still be stored, copied, or even tampered with. More importantly, what if someone just keeps watching your satellite, doesn't care if they're noticed, constantly intercepting the quantum keys, disrupting the process? That's a denial of service DOS attack, not on the message, but on the method. In short, this tech is brilliant, but not invincible. There's a darker twist in the quantum tale. While quantum physics helps protect data, quantum computing could help destroy that protection. A powerful enough quantum computer could break RSA encryption, the backbone of digital security, in minutes. Google's quantum processor D-Wave reportedly solved tasks 100 million times faster than classical computers in 2015. The implications: what once took 10,000 years could be done in seconds. Encryption that protects your bank today, a decade from now, it could be meaningless. Governments are already preparing. The U.S. National Institute of Standards and Technology, NIST, is developing post-quantum algorithms that can't be cracked by quantum computers because the math is multidimensional and doesn't play nice with quantum logic. Here's the current standoff. China is betting on QKD and satellite infrastructure. The West is investing in quantum-resistant encryption algorithms. It's like building a shield versus upgrading the armor. Which side wins? It depends. QKD is elegant but fragile. Algorithms are flexible but not flawless. What matters most is timing. Quantum computers are evolving fast. Once they reach a critical threshold, they could render today's encryption obsolete. That's why some experts fear the download now, decrypt later. Strategy hackers are already stockpiling encrypted data, waiting until they can crack it. Let's imagine what happens if China succeeds. Financial transactions would become bulletproof. Military communications secure from even the most advanced adversaries. Private emails, no more leaks. This kind of power isn't just technical, it's political. If China owns the infrastructure for global QKD, it owns a layer of trust beneath the internet. That's a strategic advantage unlike anything we've seen before. And that's why other nations are watching closely and responding quickly. In Inuin, a European defense contractor was hacked through a weak key exchange protocol. Sensitive data was exposed. Damaged millions in research, months in delays. If QKD had been used, the breach could have been stopped before it began. Yet even QKD isn't foolproof. In 2010, a team at the University of Toronto exploited a timing flaw in a quantum encryption system, tricking it into revealing keys without detection. That's the arms race. Every new lock finds a new thief. Here's the truth. Quantum encryption is no longer science fiction. It's science strategy. And we are all part of the game. The emails you send, the transactions you make, the videos you stream, all rely on systems that could be obsolete tomorrow. But we're not helpless. The tech community is preparing. So are governments. So should you. So could China be on the verge of a major scientific breakthrough? Absolutely. But the bigger breakthrough may not be quantum key distribution. It may be the global recognition that digital trust, is the next frontier of power. We must ask hard questions. Who controls the satellites? Who builds the algorithms? Who do we trust with our secrets? Because the answer to those questions won't just shape science. It will shape the future of freedom.